ahead. The question is, an aqueous solution containing 7.97 grams of lead-2 nitrate is added to an aqueous solution containing 6.03 grams potassium chloride to generate solid lead-2 chloride and potassium nitrate. Part A, write the balanced equation with physical states. First, what we're going to do is we're going to write out each element separately, each compound separately, and we're not going to crisscross yet. We're going to crisscross after. Lead-2 means lead has a +2 charge. That's what they're telling us right now. NO3 nitrate, we know it has a -1 charge. KCl, which is potassium chloride, potassium is +1, Cl has -1. And it's going to generate solid lead 2, so that's solid lead 2 right here, and chloride, -1, and potassium nitrate, which is K +1, NO3 has a -1. Now we're going to crisscross. We're going to get PB, the -1, it's a 1 over here, comes over here. We're not going to write it out. We're going to leave it as PB. NO3, the 2 comes over here. We got a 2. Plus the 1 and 1 crisscross, and you're just left with the regular KCl. The 2 comes over here. The 1 comes over here. We got a PbCl2 plus KNO3. The 1s come over. Now we're going to balance our equation. We see that we have 2 NO3s on this side. We're going to put a 2 over here. We see that we have 2 Ks on this side. We're going to put a 2 over here. Now let's see if we have everything balanced out. 1 PB, lead. 2 NO3s, 2 nitrates, and that's 2 nitrates. 2 potassiums, 2 chlorides, 2 chlorides. That's our balanced equation. We're going to write the physical states out now. According to the equation, according to the problem, this is an aqueous solution. So that's an AQ. Lead nitrate is the aqueous solution, and also potassium chloride is an aqueous solution. It says that solid lead chloride, so this is a solid, and this understandably is also an aqueous solution. So this is our balanced equation with physical states. The problem tells us that there is 7.97 grams of lead-2 nitrate. That means that there are 7.97 grams of this. 7.97 grams of lead nitrate. We're going to multiply that by 1 mole of lead nitrate. We did the math before, and it turns out to be that it's 331.2 grams. This is its molar mass. The grams cancel out, and we're left with 7.97 divided by 331.2. 0.02406 moles of PbNO3 2. The equation also tells us that there is 6.03 grams of potassium chloride. 6.03 grams of potassium chloride. We're going to multiply that by its molar mass. 1 mole of potassium chloride weighs 74.55 grams. Grams cancel out. 6.03 divided by 74.55 yields 0.0808 moles of KCl. Now, in order to see which one is the limiting reactant, we have to see which one of these will create the least amount of product. We're going to go with this product. Arbitrary, of course, we could go with this product also, and we'll see it's limiting, but we're going to go with this one. So if you have 0.08 moles of KCl, to moles of PbCl2, we see it's a ratio of 2 to 1. So you're going to multiply this by 1 over 2. So multiply this by 1 over 2, and you're going to get, this creates 0.0404 moles of PbCl2. This many moles of NO3, it's a ratio of 1 to 1. Therefore, this many moles is going to create the same amount, 0.02406 moles of PbCl2. If you compare these two, you see that this number is less than this number. Therefore, we know that this is the limiting reactant. We're going to follow this equation to see how much product we create. We found out from the previous step that we had 0.02406 moles of PbCl2. But that is assuming a 100% yield. In reality, this part of the question tells us that the percent yield is 83.8%. Right? So we have this many moles. We're going to multiply this many moles by 0.838 to get the amount of moles actually produced. 0.02406 times 0.838 gets me 0.02016 moles of PbCl2, which is the precipitate actually made. Now they ask us for grams. To convert from moles of PbCl2 to grams of PbCl2, we're going to use the factor label method. Moles of PbCl2 over 1 times 1 mole of PbCl2 weighs 278.1 grams. I'm going to multiply this, and we're going to get 278.1, 5.607 grams of precipitate.
How could it not be a actual handwriting? Honestly, I don't. What are we going to discuss?
So, how many grams of the excess reactant remain? Before we start this, let's assume that we have 100% reaction. Our reaction would look like this. Since we know from before, it's a ratio of 1 to 2 to 1 to 2, 1 to 2 to 1 to 2. We know that we start off with a limiting reactant, which is 0.024 moles of PbNO3 plus, since it's a ratio of 1 to 2, multiply this by 2, we get 0.048 moles of KCl, will yield 0.024 moles of precipitate plus 0.048 moles of KNO3, again the ratio of 1 to 2. This is assuming 100%. But the reality is that there's an 83.8% yield. So 83.8% actually react. The rest does not react. So we would really multiply all of these numbers by 0.838 to get our actual reaction. We're not going to do that because we know our focus is on KCl. We know that is our excess from before. We know that this was our excess because this was our limiting. KCl is our excess. Our focus is going to be on excess KCl. So we know that there's 0.048 moles of KCl. In reality, 0.0402 moles reacted. Now, we know from the problem that there's 6.03 grams. That we figured out was really 0.0808 moles. We're going to subtract the 0.0402 moles from the 0.0808 moles total to get 0.04057 moles unreacted. That many moles unreacted multiplied by the molar mass gets us to 3.02 grams of KCl in excess. That is our answer.